Okay, let's see how you did. First step, let's subtract over the 10x. Put it in descending order. So I have 8x squared minus 10x minus 3. And then I'm going to try to factor that expression. So I'm going to draw my box and go 8x squared there. The minus 3 goes in the bottom corner. And this has to equal a negative 10x when I'm done. So I have some options again with my 8x squared. It could be 4x times 2x or 8x times 1x. So I'm just going to pick one. I'm going to try 4x times 2x first, and if that doesn't work, I'll go back and try 8x and 1x. And then the negative 3, I'll need a 1 and a 3 in these spots, and I'm going to have to decide which one will go where. But remembering it's a negative 3, so one of those numbers is going to be positive, one's going to have to be negative. And it turns out if I put the 3 there and the 1 there, I'll have a 12x in this box, 2x in that one. And if my 12x is negative, my 2x is positive, that will give me my negative 10x that I'm looking for. So, positive there, negative with the 3. So this expression factored into 4x plus 1 times the quantity 2x minus 3. And then using my zero product property, since these two multiply equal 0, that means either the 4x plus 1 has to equal 0, or the 2x minus 3 has to equal 0, or both of them. So to quickly solve this, I'm going to subtract the 1. So 4x will equal negative 1. Divide by the 4. So x is equal to negative 1 and the 4th. So that is one solution for x. The second solution, we add over the 3. We have 2x would equal 3. Divide over the 2. So x would equal 3/2 or 1.5, 1.5. So this equation has two possible solutions. The second one, I could do it by factoring, but since it doesn't have what we call a bx term, I could just add over the 9. So 4x squared equals 9. Divide by 4. So x squared would equal 9/4. And since that's x squared, I want to take the square root of the 9/4. But if you take the square root of a number, it could have a positive value or a negative value. So that's positive or negative, square root of 9/4. And the square root of 9 is 3, square root of 4 is 2. So our two possible solutions for this one are 3/2 and negative 3/2. Now some problems, some quadratic equations are equations where your largest exponent is a 2. Your variable is squared. And that's your largest exponent in the problem on a variable. Some quadratic equations you cannot factor or solve directly. And some of you can. And so we're going to do this one first though. This one, we have a higher degree polynomial. Higher degree because instead of an x squared, this one happens to be an x cubed. But see if you can solve this one by factoring when it's a higher degree. It's an x cubed equation, not an x squared equation. Okay, so to get back to this equation, first thing we're going to do is we're going to factor out an x. Each one of these terms has an x in it, so we can factor it out. And so we end up with x times the quantity x squared, excuse me, minus 2x minus 3. And then we're going to see if this quantity still factors further. So I'm going to go back over, do my factoring. So x squared minus 3. This has to be minus 2x when we're done. So again, x and an x. The 3, we don't have a whole lot of choices. 3 times 1, so 3x, a 1x. And we want the 3 to be negative, the 1 to be positive, to make sure that this adds up to a negative 2x. So I'm going to come back over here. I still have the x out front. This is x minus 3 times x plus 1 equal to 0. So this time we have 3 different things multiplied together to equal 0. So by the zero product property again, this time we have 3 different possible quantities that could equal 0. So x equals 0 is one of our solutions. X equals 3 is a possible solution. X equals -1. Last one. As I was saying a few minutes ago, there are some problems that you can't solve by factoring. And this is an example of one. So with some quadratic equations, you can solve them by factoring or directly. But some of them, you need to have a special formula. You could solve by what's called completing the square or the quadratic formula. And the quadratic formula says that the solutions for a quadratic equation, ax squared plus bx plus c equals 0, where a can't equal 0 because if a is 0, then we don't even have a quadratic, are given by x equals -b, or the opposite of b, plus or minus the square root of b squared minus 4ac, that whole quantity divided by 2 times a. So we're going to use the quadratic formula to solve this last quadratic equation. But before we can solve the quadratic equation and use the quadratic formula, we have to make the equation equal to 0. So that means I need to subtract over the 3 and add over the 4x. Now granted, I could have just subtracted over the 2x squared, but I like having my ax squared be a positive number. So I have 2x squared plus 4x minus 3. That whole thing is now equal to 0. So in this expression now, the 2x squared plus 4x minus 3, if we look at ax squared plus bx plus c, the a is equal to 2, the b is equal to 4, and the c is equal to -3. So if we put those values into the quadratic formula, it tells me that x is equal to the opposite of the b value, so -4, plus or minus the square root of the b value squared, so 4 squared minus 4 times the a value times c, which is -3, divided by 2 times the a value, which in this problem is 2. So now we're going to do a little bit of simplifying. So we have -4 still on the outside. Here we have 16 minus, so we have 8, that's going to be a -24, so that's actually going to make that a positive 24 in there, with the minus and the negative, all over 4. So I'm a little bit out of space, so I'm going to bring it over here. So x is equal to -4 plus or minus the square root of 40 all over 4. And that's a great solution. We can do a little bit of simplifying here with the square root of 40. If you take the square root of 40, to simplify a radical, we want to find a perfect square that divides into 40. And 4 is a perfect square, because it's 2 squared, and 4 goes into 40 10 times. And the reason we do this is because then we can simplify the perfect square, and I have x is equal to -4 plus or minus the square root of 40 became 2 square root of 10 all over 4. And there's one step more I can still do here. I can still, if I look at the top, I have a factor of 2 I can factor out of these two values, out of the -4 and the 2. And so I'm going to factor out a 2, which gives me -2 plus or minus square root of 10 all over 4. Because then I can simplify those two values. So my final answer could be expressed as -2 plus or minus the square root of 10 all over 2. There are other forms of expressing that, but that is one way of doing that. And that's it for your lesson today.